So with the continuation of RS232, let us discuss about DB9 pin connections. As the name itself indicates, DB9, that means it will be having 9 terminals or 9 pins. This is a diagram, how it's going to be indicated. That is pictorial representation of DB9 connectors. So 1, 2, 3, 4, 5. That is in upper row we have 5 pins. In lower row we have 4 pins. So the first one is indicated as 1, which is nothing but data carrier detect. So second one is nothing but receiver data, and third one it is nothing but transmitting data, that is TXT. The fourth one is nothing but data terminal ready, that is DTR. The fifth one is signal ground, that means ground pin. Again sixth one is nothing but data set ready, and seventh one is nothing but request to send. Eighth one is clear to send, and ninth one is ring indicator, which is indicated as RI. This RS232 supports both DB25 and DB9 pin connectors, but we most commonly use DB9 pins much. And this is a representation and pictorial representation of DB9 pin connectors. So handshaking in 8, that is RS232. The current terminology classifies the data communication equipment as DTE and DCE. DTE is nothing but data terminal equipment, refers to terminal and computer that send and receive the data. Data communication equipment refers to communication equipment such as modems. The simplest communication between a PC and microcontroller requires a minimum 3 pins, that is TXT, RXT and ground. So that means a simplest communication where the connection between PC and microcontroller, it requires only 3 pins, that is TXT, RXT and ground. DTE, that is data terminal equipment. DTE, this is another data terminal equipment, transmitter to receiver, and this is ground. This is the simplest communication. Okay. And shaking signal in RS232 DTR, data terminal ready. When the terminal is turned on, it sends out the signal DTR to indicate that it is ready for communication. Okay, that means it is turned on, it will indicate that it is ready for communication. DSR, data set ready. When it is turned on and has gone through the set self test, it asserts DCR to indicate that it is ready for communication. Okay, it is on means it is going to make a self test, and it is also asserting DCR to indicate it is ready for communication. So next, okay, request to send. When DTE device has byte to transmit, it asserts RTS to signal the modem that it has a byte of data to transmit. Okay, and CTS, clear to send. When the modem has a room for storing a data, it is to receive. It sends out the signal CTS to DTE to indicate that it can receive the data now. Okay, it will indicate the DTE that it is ready to receive the data at right. Okay, next, DCD. The modem asserts the signal DCD to inform the DTE that it validates a carrier has been detected and that contact between it and other modem is established. RI is nothing but ring indicator, the output of the modem and an input of the PC indicator that the telephone is ringing. It goes on and off synchronous with ringing sound, as simple as like your telephone. Next, TXD and RXD. This is the simplest form of receiver and transmitter, transmitting and receiver in 8051. It has the 2 pins that are used specifically for transmitting and receiving the data serially. These 2 pins are called TXD and RXD and are a part of port 3, that is P30 and P31. These pins are TTL compatible, therefore they require a single line drivers to make them RS232 compatible. We need a line driver, that is voltage converter, to convert RS232 signal to TTL voltage level that will be acceptable to 8051 TXD and RXD pins. 8051, P31 and P30, max 232. So here, as in the diagram, it has been shown pictorially, that is 8051, when it is connecting to DB9 connector, it has to go through with max232. As we already discussed, it requires a converter, that is level converter. Here the max232 will act as a level converter in between DB9 connector, that is RS232, and 8051. Okay. PC baud rate. The PC compatible COM port, that is PC compatible computer premium, that is Pentium microprocessor, normally have two COM ports. Both ports have RS232 type connectors. The COM ports are designated as COM1 and COM port and replaceable by USB ports to allow the data transfer between the PC and an 8051 system without any error. We must make sure that the baud rate of 8051 system matches the baud rate of PC. Okay, this is a very important point. So if you want to communicate with PC and 8051 without any distortion or error, the baud rate should be maintained such that it has to match. The baud rate supported by IBM PCs are 19200, 9600, 4800, 2400, 1200, 600, 300, 150 and 110. How to set up a baud rate in 8051? The baud rate in 8051 is programmable. The relationship, that means we can able to program the baud rate in 8051. The relationship between crystal frequency and baud rate of 8051 is discussed now. The 8051 divides the crystal frequency by 12 to get the machine cycle. So we already discussed what is crystal frequency, what is the machine cycle in 8051, and we also know what is the crystal frequency of 8051, that is 11.0592 megahertz in module 2. The machine cycle frequency is 921.6. How we are going to get this? 11.0592 megahertz of crystal oscillator is divided by 12. The machine cycle frequency will be 921.6 megahertz, and again it is divided by 32 by UART, so that we'll get 28,800 hertz. Okay, so which will be fed to the timer 1 to set the baud rate. Okay, so we know that in 8051 we have two types of timer, that is timer 0 and timer 1. Next, so here this is the example we have for timer 1 must be programmed in mode 2, that is 8-bit and auto reload with a crystal oscillator frequency of 11.0592 megahertz. Find the timer high 1 value needed to be have a following baud rate. TH1 means it is of 8-bit, and we are giving a baud rate of 9600, 2400 and 1200. So when we solve this, the machine cycle of the frequency of 8051, we know that is 11.0592 megahertz. If you divide it by 12, you will get 921.6 kilohertz, and again if you divide it by 32, you will get 28,600 hertz with a frequency of UART, which will be used for serial communication, which is given to a timer 1 to set the baud rate. Now this 28,800 hertz is divided by 3, you will get 9,600, which is the required baud rate to be set, where -3, if you convert it into XOR, it will be FD, and it will be loaded to TH1, that is timer high 1. If you divide 28,800 by 12, so you'll get 2400, where -12 is nothing but F4, which is hex, which is loaded to TH1. 28,824, it is nothing but 1200, where -24 is nothing but E8X is loaded into TH1. Okay, next, setting up baud rate in 8051. The timer 1 must be programmed in mode 2, that is 8-bit auto reload. In this table, we'll come to know that for a baud rate of 9600, TH1 in decimal we have -3, in hexadecimal we have FD. For this baud rate we have -6 and FA. For this baud rate -12 and F4. For this baud rate we have -24 and E8. As you already know, the crystal oscillator frequency is 11.0592 megahertz. So SBUF register. A byte of data is transferred via a transmitted line, must be placed in SBUF register, and this SBUF is nothing but it is one of the register in 8051 which is used for serial communication. It will hold a byte of data when it is received by the received line. Byte of data means 8 bits. It can be accessed like any other registers. Move SBUF -D, which will load the 44H, that means ASCII value of D, to SBUF. Move SBUF, A, that means the content of accumulator will be copied into SBUF. Move A, SBUF, copy the content of SBUF into accumulator. These are some of the examples how we can use. When a byte is written in SBUF, it is framed by 8051 with a start and stop bit and transferred serially via transferred pin. When the bits are received serially via received, it is deframed by 8051 by eliminating the stop and start bits, making a byte out of data received and then placing it in SBUF. Framing needed not to be done by programming explicitly. Okay, next. The special function register SBUF is physically two registers. One is write only and it is used to hold data to be transmitted out of 8051. The other is read only, holds the received data from external source via RxD. Both mutually exclusive registers have the same address 099H. SBUF is not bit addressable. Okay, so next topic is SCON registers. Okay, so let us stop at this point. Now let us discuss about this in the next class. So SCON, SBUF, these are very important. They may ask you for 4 marks, 5 marks, or explain the following like that. And these are very important topic. And in lab point of view also in Viva they may ask you this, the structure of SCON and SBUF register, what is SBUF and how many bits like that. Okay, so it is very important. So let us discuss this in the next class. Let us stop at this point.